Cool. Well, again, so my name is Patrick. For you of you guys that are just joining me, I'm with the Job Easy team. I'm one of the instructors. I usually teach the introduction classes for theory, mostly to do with the software development lifecycle and bugs and explaining what bugs are and how we're going to find them and how we're going to let other people know what to do with these bugs inside of JIRA. All right, so my background, a little bit about me. Grew up in California here, but I went to school for something completely unrelated to IT, much like many of our other instructors you would have heard. I went to school for animation, so my background is actually in art. However, I did really enjoy working with computers all my life growing up. I didn't know how to program or anything, but I knew how things worked. I knew kind of like Windows system files, and that was about the extent of that. But when I got to college, I found out towards the end of it that, wow, animation is really hard. You have to put in a lot of hours, and you don't get paid all that much. And then I was introduced by a friend who's doing QA, and they were working half as less as me, but earning twice as much. And they didn't have a degree in computer science, which is notoriously difficult and kind of a long degree. So I was like, wow, why am I doing this? So I ended up having to do a very similar course as to this. And then I got started over at Facebook, being their project manager coordinator for the Rift. If you're familiar with VR, they have a headset that allows you to see things in virtual reality, right? And I was dog fooding that, and we'll get into kind of what that means a little bit later in the course. But from there, I went on to work at Intel, and we worked on some more virtual reality applications and mobile applications. And because of COVID that's happening here, some projects have been delayed, but that's all right. There's always going to be some more projects coming down the pipeline for manual and automation. All right. Let me get here, sharing our first lesson. And I will present it. Let me know if you guys will able to see the first slide, because Google Maps or Google Slides has got a bug in it that doesn't play nicely with Zoom. I think I have to do it again. Get my chat up here. Okay, you might see like a gray box off to the side of the right. That's okay. That's just my chat, so I can see what's going on. I don't currently have two monitors set up here. So, all right, this is your third lesson. I'm glad you guys are all back here and ready to actually be excited about QA and finding out that this might be something for you guys. This one is the software development lifecycle. So it's just kind of theory and introduction on how software is actually made in an IT environment. We'll find that it is very similar as to how all things are made. However, it's on a very tight time schedule now in modern days if you're working for a company that doesn't deal with the government or large projects, which is the majority of companies you'll be working with. All right, your instructors, you guys have met Yuri and Alex and Natalia and Lana and Max. Max will be working with you guys for mentorship and whatnot, and I'm sure you've already communicated with him some bit. And then I'm your instructor for today. So here, how is software made, and how is the software development process actually happen? Right, so we got a picture of here, a bunch of people visibly confused over some IKEA hardware, right? Well, how does this fit into software? Well, when you're making software or application or anything, you mostly have a set of pre-built building tools, right? You have here in this example some cut wood already. We have some fasteners, some nails, hammers, instructions. Might not always have instructions, but it's very possible if you're QA. And I think this kind of relates to software in the fact that we can think of it as maybe like software languages. We have all the tools there, and our computer working on Windows and Mac and Linux. We have all the tools there to create pretty much anything. Anything that's been made in the last 30 years is now available to the majority of you on your own laptop. I mean, that's how good our computers are now, with the exception of servers and whatnot, which get kind of expensive, but you can do so much right at home, right? It's also kind of like Legos, where you have all the necessary components right there at your fingertips. All you have to do is just kind of follow a 1-2 process of clicking anything together. And they're kind of generic. So you have, in programming languages, you have all these little bits that you can just stack together and rename things for your own continuity, so you know what you're talking about. And then you can make any software application you want. Okay, so here we have a phase of software development lifecycle. As you might expect, it goes in one direction, not like the band, but it goes in from planning to design to development, testing, deployment, and maintenance. And we'll explain what all those are in a little bit, and especially maintenance. Maintenance might not be familiar with a lot of people, but we can think of this as something like building a bicycle. So I'll use, for our first example, something that is maybe familiar to us, because not all of us come from an IT background here. So in other types of development cycles, you might go back and forth between testing and development, but for these purposes, we're going to explain it as just going straight down through the pipeline as if we're a bigger company. So the first thing you guys need to do is start in the planning section. One of my life philosophies and kind of ideas is that if you are failing to plan, if you don't plan at all, then you are planning to fail. With everything you need to do, you need to have some sort of idea about where to start, what you need to do, what materials you need to gather, how you need to get to your goal, and then what to do with your goal after, right? Because it doesn't just start there once you make something, you have to do something with it. For this example, we'll maybe use like a bicycle. And not just any bicycle, we'll make it a little interesting with a electronic bicycle, a battery-powered bicycle. And if we were a company called Company Banana, we are gonna release this. We have an idea that people are wanting to go further during COVID. They want to be outside, but not around people, and they can charge a bicycle at home, and they can go places much further away than they could just using a regular bicycle. Maybe this is the idea. In the planning phase, we will try to gather all of our necessary ideas we need for this. So like we need a budget. First off, the budget is going to determine everything that we need or can use for our project. And this budget is going to include salaries for people, salaries for new people you need to hire, such as designers and engineers and QA and marketing and legal people, also accounting and HR. All, you know, a small company can get pretty big very fast because there's many roles that need to be filled, just because one role depends on the other. So we have a budget. We also need to establish how many people we need for this project to make. So maybe we need one designer, we need 2 engineers, 1 mechanical to build the bicycle, 1 electronic to make the electronics part, the battery part. And then we're gonna need maybe 2 QA for this. And then we're going to have some deployment engineers, and we're going to hire QA or marketing and whatnot after to really sell this product. Okay, and once we have our budget and our resources, we're going to create a timeline. And then in the IT environment, usually this is like a big meeting that happens with everybody that's higher up, with project owners and project managers and department managers. and people who are responsible for the budget, they're going to put sticky notes or something all over the wall, detailing week by week what needs to happen. So our first week might be just design of the bike, design of the batteries. For like a full month, we're going to do that. The second month, we're actually going to start developing. The third month, they're going to break it down even more for like testing of the bicycle. And then fifth month, we're going to have manufacturing of the bicycle, and you're going to have some time in there for it to ship over to the United States or whatever country you're in, and then time to get into stores and send out to people. All right, so you need a very robust schedule. And then what else can we do in planning? Let's see here. We can also go in further to the detail of planning. So, and within these weeks, we're going to call them sprints, actually. So you'll learn a little bit later in Agile and Scrum development that your week-by-week basis or your weekly schedule is actually going to be called a sprint. And we'll get into that a little bit later. But say we have our bicycle, we know who's working on it, what features it needs. So we're going to also implement what this bicycle should actually be doing during the planning phase. And then each feature or each idea, we're going to simply call a feature. And you're going to hear feature a lot for the next however many years your career is. Okay, so having an on-off switch on the bicycle is going to be a feature. Having disc brakes on your bicycle is going to be another feature. Having a rechargeable port on your bicycle is another feature. Okay, having the ability for the handlebars to go all the way around in a 360 is another feature. Okay, so let's say we have 6 features. And then we have a design person. We might have a, in this case, it is a industrial engineer, industrial designer, comes through and makes the bicycle. IT is usually a UI, user interface, or UX, user experience designer, and it comes in and will design the application for our bicycle. They're gonna pretty much lay out everything that we need. It might not be a physical representation. It's probably just gonna be a drawing, some close-up samples or whatnot. And then once we have this, QA might actually be kind of hired at this point. And I'll talk a little bit more about QA. Be sure to remind me about where we come in on the process, because depending on what company you're at, we can either be at the planning stage or at the development and testing site. So once we have the plan down and the engineers start working on this bicycle, they might actually have us come in. And then as the engineers start making this bicycle, they're going to make the frame, and then they might hand it off to QA to like test the frame, and then put bicycle wheels on there, might test the wheels, make sure everything's good to go. And then they'll add the battery. QA will test the battery. And then they'll add maybe the handlebar brakes, and then QA will test the brakes. Once the engineers have put all their finishing touches on everything, they're going to then hand it to QA for integration testing. And integration testing is taking all these small components together and testing them as one big product, one big feature, and making sure that they all work together, because sometimes features or what have you inside the app will work fine on their own, but once you mix it with something else that they're working on, another feature, they kind of conflict together, right? And then this is where we find a lot of issues, actually. And then once we, as QA, sign off on everything, as we say that, okay, yes, there are this many bugs, engineers have fixed them, there's 2 bugs left, they're not very critical, they're not very high in terms of the functionality of the bicycle. Let's just say that 1 out of every 10,000 bikes has like a paint defect where the paint kind of chips off. And for us, 1 out of every 10,000 is pretty acceptable. So QA says this is good to go. We give a stamp of approval, a seal to our manager saying this is good to go, and then they ready it for deployment. Deployment in IT probably looks like a deployment engineer that makes sure that the application works for everybody it's intended to. So maybe this is an actually IT application that's meant for both people that are using Windows and Mac and Linux. And if you're familiar with these, they use different installers. They require different dependencies within the operating system itself. So these engineers make sure that the app is able to use all these so it works correctly, because you can't install an application that's meant for Windows on Mac and vice versa. And you can't use something on Linux that's meant for Mac or Windows. Our deployment engineers have set this out. It's gone to marketing, our bicycle, and we put it on a store. And then we get to this, what's called maintenance. So after people are buying it, the customers have gone through and received their order, their bicycle, and they're finding maybe more issues at this point, because I'll let you know as QA that we can't possibly find everything. It's impossible. Some bugs will escape no matter how hard you test and you feel like you've got every corner covered and you got enough coverage. People will always still find an issue. So maintenance basically means that we're going to continue updating our design, making it better. We're going to receive user feedback, and then we're going to incorporate that back into our design to make sure it's accessible for everybody. During maintenance, we might also, I'll touch on that a little bit later. Okay, so get into the nitty-gritty of this, the actual planning. So we'll start using IT examples here. This is the first phase of the software development process. It identifies necessities for a new software to achieve business objectives. And the purpose of this step is to find out the scope of the problem and determine the solutions. So planning is really finding about all the contingencies. So maybe we have, we're in the city of Colorado, and this is our business, and I mean the state of Colorado. And we have a problem where we don't have enough engineers in the area, right? So we have to find a solution for this. We have to either hire abroad or try to entice people with package incentives like more pay or better benefits to come to us. Or we might anticipate something with maybe their Bitcoin is going big again and everybody's buying graphics cards and memory. And so the cost is actually going to go way up for our production because these things are now rare. So we have to figure that into our planning, our resource allocation, right? So you're not only looking at just our product, but also the ability to how to make it. That goes to the requirements. So QA is not necessarily always in this first planning phase. I will say that I haven't necessarily been in there. It's one for kind of like a QA manager department head, somebody that kind of reports directly to the product owner. Because this part, QA is not necessarily vital. It is helpful if we know what's going on from the start, but there is a document that is created through the planning phase called the PRD, the Project Requirements Document. It goes through some other acronyms as well, like a PRT, but I think you'll almost always hear PRD, so Project Requirements Document. Write that one down whenever you guys got to do. You'll hear it again from myself in the next lecture and from Natalia and through all your courses here. But this document is a comprehensive list of all the features in this product. Let's make an application for iOS, your Apple phone, and you want one for Android, like for everything else. We're going to have this application be able to post images and comment and give thumbs up, right? That kind of sounds familiar. I don't think it's a super crazy complex application, and it has just 3 features: posting pictures, commenting, and giving a like or heart button thumbs up. Okay, so we're going to allocate our resources. We got our scheduling down. We know how much it's going to cost. And one of the big reasons why QA is actually not in there is because they need to keep the cost estimation down. If they're paying everybody for everybody's time, right? So if we're in the beginning and we're not being super productive, where we can be productive later in the project, that's what they'll end up doing, is hiring us a little bit later. Okay, so once we got the capacity, they've hired all of our engineers. Maybe we need 3 engineers for this, 2 QA, and then all the other supporting business roles in there. They're going to have this meeting, and then a couple weeks later, they're going to go into design. Once the requirements are understood, software architects and developers can begin to design the software. The design process usually established patterns for application architecture and software development. System design helps in specifying approach to development and defining overall system architecture. In this phase, QA comes up with a testing strategy where they mention what to test and how to test. There's more to it than this. This is maybe engineers will start working on the background to the application, the architecture, which is a framework. It's kind of like the, think of it as, in terms of Lego, it's that green large piece as you would use for the floor, right? Where you can start building everything off of. And they're going to have modules that you can make so you can plug all your code into, and it works very nicely. So maybe in the design phase, they've hired QA for this example. And they've also hired a UI, user interface, or UX, user experience designer. This guy or gal designs the look and feel of the application. They're going to make a little mock-up of it in kind of like a Photoshop paint type application, usually called Zeppelin, but there are many else out there. It's not going to have any real functionality. If you click on something, it might take you to the next page, but if you click on the shopping cart, it doesn't have anything in there. You can't add anything. You can't take anything out. You can't log in. It's just really to show you what it's going to look like and how it's going to feel. And they're trying to get the real experience out of the app. Is it going to have sounds? Is it going to have a transition pattern if you swipe up and down? Does it have a fade or like a swoop? Does it use lights or flashy catches? What kind of style buttons are going to have? Where ads might be? Okay, so the UI guy makes this, puts this into the PRD, where we have all of our features, all 3 of our features. And these features are kind of laid out where it has details of them. So for the posting a picture, it will say, what is the story? As a user, I want to be able to upload a 640 by 480 picture on our application using any type of internet connection, and that'll be it. There might be some other details about it, like how fast it needs to upload, or if it can include certain file types. So maybe we'll include .jpeg, .png as well, and maybe .gif, so you can have like animated pictures. And then this feature, this detailed list, is going to be what the engineers also look at as well, and everybody working on the project. That's how they decide how to actually make the project. So the engineer, during the QA, this is where we can kind of start coming up with our testing strategy, how we're going to go about testing this. Not necessarily what we're testing, but how we will do it. So testing strategy might incorporate ideas like we're going to need the ability to stress test our application for 500,000 simultaneous users, because a lot of applications crash when there's too many people on them. So we need to think ahead. Maybe when this is launched, it'll be popular, that we need to account for this. We'll need to come up with a strategy that entails more week by week testing. So maybe the third half of this, we'll do integration testing. The first half, we will focus on testing on just the picture part. And then the next month, we'll focus on testing the other feature, which is the comments. And then finally, the last month, we'll focus on thumbs up. And then at the very end of the project, we'll test it all together in integration. This is where they usually hire like a QA manager and a QA lead. So let's think of it like that. And then we have development. This is where the nitty-gritty comes in, where most of the work happens. This phase involves the actual coding and programming of the software of our application. After the requirements and design activity is completed, the next phase of the software development lifecycle is implemented in the software. Developers also write unit tests for each component to test the new code that they have written. They review each other's code, create builds, and deploy software to an environment. This cycle of development is repeated until the requirements are met. So the last phase here, developers will, don't let them think that they're stepping on your toes or that they're doing your job or anything, but developers will write what's called a unit test. As they're programming in whatever language that they are, most common are kind of like Python or Java right now, Ruby and React Native. They will, say for the picture part, the engineers working on the first part where they're trying to create an uploadable image, that they'll just write a quick test. You don't even have to write it. They'll just maybe make a build really quick. They'll put it on their phone and see that the picture does indeed upload before giving to QA. And why are they doing this? Well, it's because programming is kind of complex and you don't know if what you're doing is actually going to work 100% for sure. So you just want to quickly check, just to make sure it works before you get to QA. It's not going to be detailed. It doesn't, they're not looking for a ton of bugs. Maybe the picture is scaled too big or scales too small or has defects in it. They're not concerned with this. They're just seeing if it merely works. Okay, and then in development, the requirements, actually. So let's go back to the PRD talking about that. We will also have, during the development phase, the longest, kind of like milestones. And these milestones are ways to keep track for management, because your product owner is not aware of what you're doing day to day. They want to have an update. So when we reach these milestones, they're like, okay, maybe there's an additional month we need to add because we got to this milestone 3 weeks late. Okay, that's all it is. You will hear the words alpha, beta, and production or gold phase. And then these phases are like alpha is a very early stage of the program. It's met that maybe our application is able to upload a picture and then we can put some words in there, but we don't have a thumbs up button. That's not ready yet. Maybe it's limited to 140 characters, and then that's good enough for us. We can say this is a small working version, and then the small working version is called alpha. Usually this is the phase that's just enough ready to actually start testing on and then letting other people see it without seeing everything that happens behind it, right? It looks close to what the designers, the UI, UX people had originally created. The developers are then, they're going back and forth, looking at the PRD, trying to look at each feature, how it's written, and then interpret that, and then code it, program it, and then create a build and for us to QA. And this is going to go back and forth quite a bit. The beta phase is more requirements are met. Maybe the pictures include all the file types, JPEG, PNG, GIF. You can put comments. You can like as many times as you want according to requirements. And that would be the beta phase, where it's pretty much always done. It just needs a few places to kind of sharpen up. Maybe we need to prepare the backside for deployment. And that's the only thing that's missing. We can support 100 users, but not 500,000 users yet. Okay. And then we're going to say that's good enough for us. And then during the beta phase, we're going to let more people from the company actually look at the product. And then that's what I did for Oculus, was I was there to take the headset and then get feedback from everybody else inside of the company. We weren't going to release it to the public. We still wanted it to be a very kind of sought after launch, make it really exciting for people to get something that was leading edge technology at the time. But we needed our own people to use it and figure out issues with it before we give to consumers. And that's called dog fooding. Coined by Microsoft, it is eat your own dog food, which means that you got to use your own product. A lot of companies, a lot of CEOs don't actually end up using their own products, so they're very out of touch. All right, and it's easy to see this because they're busy doing all these other things, and engineers are making iterations every day, and then they don't have a chance to actually check it out and use it for a full day. Okay, so now we get to the best part, in my opinion, the testing, where we come in. During testing, QA starts to test the software against the requirements. Once a defect is found, testers inform the developers who will fix and create a new version of the software, which needs to be verified again. Okay, so this is kind of like the old way. This, for background, is kind of created back in the early 2000s. I mean, before the 2000s. It was how everything mechanical that was made post-industrial revolution, everybody kind of used the same testing plan, the same development plan here. So, but when we do this back and forth, this is kind of our new age after year 2000, started using Agile. So requirements are that developers create some features, QA is going to test them back and forth. We're going to say that something is broken. Maybe the pictures fail to upload every 100 times that you upload a picture. We're going to give that back to the engineers. They're going to fix it. We're going to verify it. We'll say that another bug is found, because often when you fix one thing or two things, something else pops up. So you'll often find new bugs as you create new ones. And then this will go back and forth. Usually you'll get like a build every day or maybe every 3 days, depending on the schedule. And you'll just keep verifying, making sure that going through your test plan, that you're capturing all the different features and making sure that they're all been verified. Excuse me. This cycle is repeated until all the requirements in the PRD are met and the testing of all the defects have been fixed and the software is ready to be shipped. Again, not all the bugs can be found during testing, and I'll give you a great example of this. Security is a big issue for applications and companies, especially things like the iPhone. They're really all about security and protecting user privacy. So in order to really get the best product, Apple has made a bug bounty. So you can get upwards, I think it starts at about like $100,000 or $500,000, where if you find a bug in an iPhone or Mac OS related to security and you report that to them, they will just give you $100,000 or more, depending on how good it is. So they're very, very serious about this, and then they're willing to put their money where their mouth is. Okay. And also, if you guys are into video games or have heard something about Microsoft Flight Simulator, which is more of a simulator than a game, there's bugs popping up every day because they're putting new patches and some things are going wrong, and it's very evident to users. Okay. So here we have, in the testing phase, we have our QA testing software that we're going to be using, which is most likely JIRA and TestRail. And we'll have you guys using this a little bit later in the program, and I'll show you briefly what JIRA looks like. It's just a project management tool and a bug reporting tool all merged together into one thing. It's really easy to use, simple. It'll take us about like a half an hour to learn. Okay, test cases are written and executed. I will say that test cases are usually written as early as possible, so you have as much time to work on them and think about how you're testing things. In a test case, for example, might look like for the picture, say the comment box, that verify user is able to add only 140 characters. Bam, simple test case right there. Majority of test cases sound that simple when we're writing them. And then another one might be verify that only regular numbers and letters are used in the comment box. Right, another example. And then once we got all these reported and fixed, we're going to do a sign off on this. We're going to tell our manager that yes, after the beta phase, we found that these are all the outstanding bugs. There's 2 bugs left. Say that maybe I don't know, we can say that the pictures are sometimes, if you upload it in a very wide aspect picture, there'll be cropping issues. They'll say that's a bug, but the majority of people that are submitting a wide aspect picture are very low, maybe like 0.05%. So we'll just mark that, we're aware of it, and we'll fix it in maintenance. Things like that. We will always try to find all of the bugs before release, so at least that we are aware. And as a QA professional and someone working in IT, it is very, very, very important that you test all the things that you say you have tested. Do not, under any circumstances, have a test plan, test strategy, your product. Say that the time is running low, maybe it's Friday night, and you were supposed to have your testing done today, and you didn't do it. Maybe you're focused on something else, wasn't enough time, but you told your boss that, yeah, the product works. This application works. In your head, you're thinking, well, it worked on the last build, so this build should probably work today. I think I'm safe. No, never do that. Always test what you say you're going to test. If you didn't test it, that's fine. Just let them know. They can readjust the schedule, but you'll get in very big trouble if you say you did something that you did not. Okay, I've seen this happen. Okay, after we've tested everything that we say we have tested, once the product is tested and ready to deploy, it's released formally to the appropriate market. Sometimes the deployment happens in stages as per the business strategy of that organization. There'll be limited segments and testing to real business environments. Sometimes they will release a product to first, like, businesses. Maybe this product is meant for everybody, but they're going to give it to some businesses first to just try it out, and then they'll get some user feedback from them first, and then they're going to release it to everybody else. Another thing that kind of happens is a public beta, where they will take the product that's in its beta form, back when we're still in the development and testing phase, and then give it to the public. That has its pros and cons in that it kind of diminishes the excitement for the product. Lots of news blogs will report on it and show off all the features, and some people have gotten to test it, and the excitement from there kind of dwindles down. But however, you're getting a better product out of it because people are finding issues before it's launched. And how many times have you guys bought something or a piece of software or a game where you get an update the first day that it's out? You bought it first day, you install it, and there's already an update, right? It's a little bit ridiculous. Okay, so as soon as the product is available to the customers, QA executes a sanity test while users do the beta testing. A sanity test is something that's very quick, excuse me, where we're just going through the top layer of the features. We're not looking very hard. We're not trying to stress test anything. We're not trying to upload a picture that is, 50 megapixels, something that we can put on a billboard, right? We're just trying to use it the way it was intended. And if we find something there, then we can note it. If there are any changes or bugs are caught, then they'll be reported to the engineering team. That's great. And then let's see here. Does the company give you a daily list of items to test? Yeah, something like that. It'll be a test plan where there's a list of test cases, and say you'll go into a meeting for the day. Every day there's a meeting usually, and then they'll say what you need to work on for the day. And then let's say it's the comments section. Okay, great. You can just refer to your comments test list of all the test cases, and then you can execute that. Sometimes test cases are already made for you, sometimes they're not, but if they're not, we'll show you how to do it, and it's pretty easy. And then we get to the maintenance. After we've deployed it, everyone's bought this application, or they've looked at all of our ads on there, right? A lot of applications are free. They're just vehicles for ads. The maintenance phase of the software development lifecycle occurs after the project is in full operation. It can include software upgrades, repairs, fixes. This is when we're going to issue an update. Product analysis monitors user feedback. So this is what happens when your app is asking for permissions and whatnot. They're actually collecting data on the application itself, not necessarily your phone. They might get details of your phone, like it's a iPhone 10 or it's a S8 Plus or something. And then all the details in the application. So they're not going to see your name or your carrier or anything like that. That would be kind of illegal in some countries. But say the application crashes, which does happen, and then it has this little pop-up, right, where it's, do you want to notify the developers and send a report? Well, this is what they're asking for. It's your feedback on it. It's asking everything that happened in the application so they can see where it crashed and why it crashed. Because as QA, like, especially in the mobile phone market, we don't have access to every single mobile phone that everyone's going to be using. It would cost way too much. It would take way too long. I think at one time I was testing 100 phones, and that still wasn't everything. We wanted to make it pretty good, but that's beside the point. So you have to pick and choose a couple things, and that happens in the planning stage, right? Okay, so the QA identifies bugs that weren't caught during the testing. So users are coming back with these issues. We're putting them in JIRA, and then engineers fix these, give new updates, yada, yada, yada. The maintenance side is kind of where we'll start to transition to new products as QA. We're not so concerned with the product here that we had just created. Once this happens, you almost immediately get offboarded to do like another project. You'll maybe be working on 2 projects at the same time. All right, the fundamental problem with program maintenance is that fixing a defect has a substantial chance of introducing another. So the whole process is 2 steps forward and 1 step back. And it's kind of like what I said, where you fix one bug and then you're gonna have another one pop up right behind it. It's like whack-a-mole, if you're familiar with this game. You have to just keep going back and forth, and eventually you'll get there. It might take some time in the beginning because there are many issues that have to be rectified in the beginning when they're starting to engineer the program, but they eventually get to something that looks pretty good. If you guys have any questions at this time, go ahead and send them in the chat to me. We can answer some things here. I'm sure there's some questions. And then we'll start our next lecture here in a couple minutes. I know it's also kind of a dry subject. It's all very theoretical, but as long as we get this part covered and you guys are familiar and confident about where your place is in QA in the office and how you come into a project, you know, that's kind of our focus here. Most of the time when I come into a project, it's kind of usually in the beginning engineering stages, or maybe the end of planning. The main thing when people are looking for QA and hiring is that they want to see that not only are you good at making a test plan and being able to find bugs, but they also want you to know how to fix them, or maybe at least provide solutions as to why they are being caused. You might not have the solution because you're not a software engineer, but you might have an idea as to why they are happening. So I came from an animation background, and we were making a VR app that's in a game engine called Unity. It's where most games are kind of made nowadays. It's a very popular engine. And I saw some visual defects, some textures, some picture images looked like they were like backwards or kind of flashing. And I was able to provide solutions or reasons why this was happening because I knew why this was inside of when I was doing animation. You might also be able to get the source code when you're doing these projects from GitHub or wherever the repository is, and you can look at some of the code and maybe you might find an obvious mistake. Maybe there's line 3000, there's like a extra, like a grammatical syntax error or something. Is this something we need to know for a job interview? Just wondering. You don't, and during the job interview, you don't necessarily need to know how to fix what they're working on, but you need to be eager in showing that, yeah, you want to be able to provide your input for how to fix something, not just being a body to just test. That's what I've taken back so far from quite a few interviews. Can you get one example where one bug gets fixed and another bug occurs? Sure. So they're making optimization updates to the simulator, this flight simulator, where it's notoriously hard to work on your PC. It requires a good graphics card. So they tried to fix the optimization and make it work faster, more frames per second. But in doing that, they made it run faster. They also introduced a whole bunch of graphical bugs where the ground is now going like 300 meters in on itself and making a cave and making really tall buildings, and some of the textures aren't good. So it's creating one thing after they fix another, and they're most definitely related. Do QA get involved only in testing phases? Nope, they're usually actually more active in the development phase when they're working with engineers, because as you'll learn in maybe 2 more courses about the Agile Scrum environment, where things are more fast-paced, you have 2-week schedules called sprints. So you're constantly getting a build and then testing that build with your test plan, giving it back, and then they fix it, and then they give it back to you again, and fix it, verify, and so on and so forth until the project is completely done. Does it help to have a project management background experience when looking for work as a QA lead? Definitely. That would be a plus for some employers. It shows that you have the ability to plan and look for risks and dependencies. Risk might be looking at a schedule for holidays, or thinking about the lead time to hire new people, or how long it actually takes to test something and how it affects other testing. But it's not necessary. I mean, I would think that most people become QA leads and then project managers. So, and that's kind of like how the path works. You usually become like a QA analyst, then a QA lead, QA manager, and then from there you can pretty much become any kind of manager you want with the proper certifications. There are project manager certifications, and it's a good course. It definitely makes you think a lot outside the box. So, all right, let me start our next project here. Okay. Companies still need QA engineers after the product is finished? Yes, because during the maintenance cycle, people will come in with bugs from the users, or we might still find them after, and we have to interpret these bugs for the engineers, or be able to triage them, which means putting them from a ranking system with most important to least important, especially if you're continuing to provide updates. You'll still want QA there. So that's not kind of where our job ends, but they'll start transitioning us to other things, be more productive. So this is the, let me get my chat up here. Excuse me. Still recording. Introduction to JIRA, bug tracking system, and the bug lifecycle, and the resolution of bugs and they're fixed, and discussing the GUI. It's pronounced GUI, or graphic user interface, testing and terminology based on web applications. So we'll kind of do this in the thought that we're testing a website, right? Really simple website. Again, our instructors. Okay, I'm sure you guys heard this in your first course, but just to kind of reiterate, a software bug is an error, flaw, a failure in a program which causes it to behave incorrectly or unexpectedly, not as designed, right? What do you mean not as designed? Okay, that's, well, we're going to refer back to this PRD again. If it's not in the PRD, it's most likely a bug. So I also like to think of bugs as being two kinds. There are specified kind of bugs and then implied ones. Specified ones might be an issue in the with say our website that we have a test case for. We've actually accounted for this bug that might happen, and it's in our test plan, our test strategy. An implied one might be something we haven't thought of and is not really warranting a test case to have, though if it does come up, we should have one. But we're thinking ahead and we're thinking, okay, this is a very low ratio that this might happen in. So it's kind of like implied. Example of this might be, oh gosh, maybe you're uploading a picture to a website and you know, there's like some defects with it, just like compression issues, depending on how you upload it. Maybe the compression program is not that great, so there's artifacts in the picture. We're kind of assuming that most pictures nowadays get uploaded in a pretty good quality, right? Specified one will be like the picture uploads on our website in the correct area, because we can designate areas to replace pictures. You know, the left quadrant, left quarter quadrant. And yeah, so there are actually quite a few reasons why bugs pop up in software. But the root causes of defects can normally be classified into a couple of things over here. So our number one thing is usually miscommunication. And then you'll have your engineers kind of argue with you about like, oh, this is a bug or not a bug. I just kind of, it's just different. But it's not according to design. So what kind of happens is you'll be working on a project, you've read your PRD, the engineers read the same one, and then they create something slightly different according to the PRD because of interpretation. They've interpreted it differently. So they have an image in their mind of how this software might look, how this website, and it might be different than the managers they thought, the product owner. And then maybe they didn't sync up. Their first iteration of the website that they had created is completely different than what the manager was expecting in the PRD. And that actually happened at my other job here. So this guy was hired to create a little kind of a small website we could log into to manage video feeds like a video producer might see. Like if you guys see people in sports, or if like back in Jeopardy where you have like the control room where there's people switching levers and knobs to get different pictures for your TV, there's multiple cameras. We wanted something like that, but in a just a website form. And the guy was making something, he was working on it pretty hard, putting in a lot of hours, and he finally shows it to his boss, and it's not what it's supposed to look like at all. And he's actually pretty angry because he had just wasted 2 weeks on this. So there's some more kind of drama with that, but these are some things that actually do happen. And then as QA, what are you supposed to do if you get something that's completely unexpected, not as designed? Well, we can classify the whole thing as a bug, or we can just wait for the next iteration, right? But most of the time, they do happen because of communication. And then every day, you're going to have what's called a stand-up meeting, where everybody in your department, usually your department, but also sometimes, depending on how big your team is, you'll have your QA, your engineers, your project manager in a room, your product owner, and then you guys will talk about what you guys did yesterday, what you're planning on doing today, and then anything critical that's happening that's stopping you from continuing your work for today. So those are 3 things that you touch on for that day. And maybe somebody interprets what you had said for the day as something else, right? And that's another area for miscommunication. Software complexity is another one. So when we start getting into really, really big businesses, their software gets really complex because there are not just the application that you see, but there's everything that happens behind it. There is what's called the front end and then the back end. The front end is everything that you see as a user, as a consumer, as the client. And this includes all the flashy images on the website. So you can see the logo, you can see scroll bars, you can see images and text and like a cart, a login button, whatnot. The back end is going to be everything that the engineer works on that just kind of looks like code. So this will include like a database. It's a lot of databases usually. Where to store your info for your login and whatnot, where to store images. And this all gets put onto a server where these two can communicate back and forth. Right? So when the buttons are communicating with the server on the backside, there's areas where you might find a bug. For example, Amazon website, it looks very simple from the front as a user. It kind of looks like it did maybe like 10 years ago. It doesn't change much. But the backside is very complicated. I couldn't even begin to explain too much on it, but there's a whole system of like, now they got AI implemented in their website development and whatnot. And also that, like if AI is making changes to the website, maybe things are happening automated, who's overlooking this? Right? There still needs to be QA to check whatever is happening is actually the intended aspect of it. And then changing requirements. Changing requirements happens all the time. So let's say we have this Amazon website right here, and then they wanted to put Prime Video in there. It used to be just a book selling website where you could sell also lots of like Chinese goods and whatnot, maybe some homemade ones. But then they wanted to also incorporate something that's like Netflix right into the website. That's a whole different complexity, right? You're taking two platforms and then merging them together. I'm sure we will find some bugs there. And then there's also some websites we'll give you as examples in a couple of classes where you'll actually look at websites and find your own bugs in there. And you'll be amazed as to some things you'll be able to find on when you start looking for bugs. Now that you know what a bug is, you'll be able to see this. So when features change in the middle of a project, it's called feature creep. Features that were not originally intended to be in the product. Maybe they happen during the development stage, late in development stage. The good idea fairy comes and says, hey, we need to not only have Prime Video, we need to have picture inside of the window. We don't want to open up extra windows. We want to be able to share the video with friends at the same time because COVID is happening and lots of people are inside. They want to watch the same things as their friends are watching at the same time. So we'll make that another feature, watching things at the same time. And now you have to add on extra time to your planning to incorporate this. This is going to add weeks or months to develop, and then additional weeks to test this, right? Poorly documented code is another area. So for engineers, they are expected to not only write things, but also document what they did. And this is QA as well. You'll make your own reports in JIRA to your manager in kind of a non-specified form. They'll ask for what they want. But for a software engineer, they should be documenting all the additions they made, any code that they removed, and then what their changes are, and then what these changes actually do. Because when you program something, it may not be very evident as to what the function of it is. You might have a string of code and it's a login, but it's kind of hard to tell what that actually is unless you're an engineer. So you'll just put like a quick note in there in the code itself saying login platform page, and that's good enough. They'll also update the deployment manifest. So the next build, if they change the login, as QA, you don't know what they changed yet. So you get this build, and it should have a list of changes in the description of it, what they did for that day. Because I've had situations where I get 3 builds in one day, and the engineers haven't documented. They haven't even sent me a Slack message as to what they made changes on, right? So I would be lost as QA. I would have to go back to them in Slack. I have to ask them politely, what changes were made? What did you update? What areas do you think I need to test? It's just that easy. If you ever have any problems or confusion as to what changes are made, communicate with your engineers. As QA, you are kind of very buddy with the software engineers. You want to know what they know and why they're doing it. And then also QA has a different mindset usually than software engineers. So this might be another reason why there are bugs. They are thinking in a very logical, methodical way, focused entirely on building. As QA, you are focused on usability, how well this works according to the PRD, what we need, and then also how a user is going to use it and why they want to use it. Because a user will use something differently than the mechanical or the software engineer intends. So I found some bugs where I would switch between um, two tiles where you could like click on and it would show you different videos for a VR app. And if you clicked on these two tiles back and forth enough, it would cause the whole app to crash. And then my engineer told me like, well, it's not really a bug. Like, why would anybody do this? Well, I don't know, but I just did it. So if I can do it, a user's going to do it. And if they do it, then that's obviously an issue that we need to rectify. So you need to be the advocate for the consumer and try to find all the ways that somebody might exploit our software, right? Also, software development tools is another reason why there are bugs. So there was recently, in the last couple of years, is an update to Python. If you were making your project and you're programming in Python, and all of a sudden it switches to the new version of Python, and it's got some new features in there that you want to use because your project manager had a good idea and wants to implement some feature creep, wants to put a new feature in there that is only done with the new version of Python, well, there might be some bugs because new and old versions of programming IDEs don't play very well with each other, especially if they're not backwards compatible very, very well. So those are things that actually happen quite a bit. Software gets updated all the time, and your project might not fit within those windows of when your tools that you're using get updated. And then lastly, time constraints. That happens quite a bit. So I've never had a project go entirely from plan, from starting on the week it was supposed to start and then ending on the week it was supposed to end. Usually it starts off well. The first month or two, everybody's on schedule, but then the requirements change. And then the software gets more complex. And then something updates. There's a new version of Slack and Jenkins, and all these things happen. And you get pushed back further and further, maybe a couple days, a couple weeks, and then it starts to cascade and it turns into like a month. But sometimes there are very firm dates where you have to deliver something on a very specified day to a client. And then you'll get a kind of a crunch time where most people, especially the engineers, will have to work very late towards the end of the project. If you have a good project manager and a good QA manager, you will account for this and you will try to ensure that there is no or very minimal crunch time, right? Because it's very hard to work on something when you're tired and you've been stressing about it and you haven't had time to decompress. So, if your engineers are getting very tired and they haven't had a day off in a while, they're not going to perform well. Maybe there'll be more bugs. And that goes for QA as well. We can end up having to test quite a bit. Maybe you're focused entirely on testing and looking for things that are obvious, but you haven't focused on the unobvious, things that are not necessarily clear to everybody. I've been in rooms with people where we're looking for something in a closet with 3 other people, and it's in a cardboard box. We're all looking around the room. None of us can find this. And 2 days later, someone walks back in the room and finds it immediately, right? Because we're all thinking the same way. You need people to think slightly different. Okay, so during these stages, where are we most likely to find bugs and report them, and where we create them? So it's usually in the development stage is the number one, right, where it's being created as it goes. The development phase, bugs are reported mostly by developers, which is why you shouldn't feel bad if you think that developers are stepping on your toes again, because they're doing their small unit tests. And then maybe developers can make bugs for things that are on the back end or that are white box. Black box, excuse me. where you don't know what's happening inside of this program. You kind of are only testing manually the user interface. So developers can then report bugs for the programming side of it, right? The whole backend. That's something that happens quite a bit. You know, and they wouldn't be issues that we are as QA privy to. There's no reason why we would know why something is a bug in Python if we weren't hired to know Python to do our QA, right? You don't always have to know programming languages, by the way, to do QA or manual, and you'll find that in our program. During testing, this is during this type of life cycle, this is where you would find the most of your bugs. If you're doing testing all at one time, you're also going to triage them. So if you get, say, 500 bugs, you found them, most of all of them, well, you need to figure out which ones you need to work on before the other ones. What's most important? Well, how do you figure out what is most important? For me, and what I've learned is it's usually things that affect the ability for the app to make money, for the users to access it, right? So if those things are being affected in a pretty critical way, then they're going to be top priority or critical bugs, or maybe blocking. Bugs that are say, like a typo on the About Us page of a website, or a typo several pages in where not many people would see it, these would be low priority. But if there is a typo on the main logo page of the front page, the main logo section, that could probably be a high priority because it's what everyone's seeing first. It's what everyone associates with your brand. Things, if there's a bug with ads, if the ads are not showing correctly, if there are bugs with the shopping cart, things like that, to access payment methods. And then finally, bugs that cause the application to crash. They're also high priority. If you have a bug that crashes your app, that's always number one. You put it as a blocking or critical, and then we'll try to fix those first. But things like image cropping and typos are usually very low. And then for the maintenance, after the software has been released, bugs are still being reported by employees and users. We're still going to triage there. That's right, when QA is coming off the project. But maybe we're still going to work on it for a while, maybe both of them. Sorry here. Where we will continue just looking at it and triaging. So again, we find most of our bugs in development and testing, and mostly maintenance a little bit. Because hopefully you found them all. We're not always going to find every bug, but you'll at least be aware of the ones that you release in your report. Okay, so what does a bug report actually look like? Right? There are several items here we see on our list. Not all of these are things that you need to memorize, but you should be familiar with these things by the end of the last couple of weeks here. All right. So you'll have a program called JIRA, or at larger companies like Apple and Facebook, they use their own bug reporting program. It's not anything fancy usually. It's usually just very basic. It allows you to assign a severity, priority, and bug title, and then who it's assigned to and who made it. Those are usually the key things in most bug report programs. And then the ID, which one it is. And they all have some variation of this. JIRA just lets you do all of this, but also allows you to create a project report where you can add things called stories. And stories are just details from the planning stage, like developer John needs to work on creating the login shopping cart page. And that would just be a feature that telling developer John what he needs to work on for the day. And it'll look just like a bug report, except titled differently. So You'll know what I mean on the next page. So we hear the bug title. First things first. An attempt to access website results in 404 error. 404 error is just unable to connect to the website. It's not the user's fault. It's something that's happening with the website. You can't establish a connection. Maybe the server is powered off. Maybe it's down. Maybe there are incorrect internet settings. Things like this happen. This is called an error code. So there's 404, 401, and several others that you can Google to get familiar with. The bug title, we want to have a very clear and concise title that doesn't always have to be grammatically perfect, but it should tell you what the problem is in this attempt, or the situation is that it's the 404 error, that's what it is, and where we found it when accessing the website. Okay, so where we found it, accessing the website, and what it is, the 404 error. Very simple. Don't write 2 lines, 3 lines. Don't put half a line, just one simple line that describes what it is and where it happened. The bug ID is automatically generated for you by JIRA, so don't worry about that. It'll usually be a prefix. It'll say like, if you're working on Amazon website, it'll be like AMW, Amazon website, 1, 2, 3, 4, 5. Severity, high. Wow, why is this high? Because the user is unable to access the website, to do anything. It can't get you to seeing ads or spending money or viewing the website for what it was intended to do. All right, we can't browse our favorite books or our favorite Amazon Prime movies. For priority, it's a blocker because it blocks us from attempting to access the website. Because we have other test cases we need to execute just getting to the website. For example, maybe we're just checking to see if a new logo had updated. This is our test case. So we would try to go to the website, amazon.com, but we get this issue. This is our first bug. So it's blocking being able to do our test case. Prevents you from doing anything else. And then it will create an assign to. Usually your QA manager will assign this to somebody, or the Scrum Master. You will learn about that a little bit later, but just someone else other than you usually assigns this. If it's a small team, say a team of maybe 4 developers, and you know that developer John, his responsibility is the website backend and dealing with connection issues, you can just automatically assign it to him. But whatever your manager wants. The reported by will be, in this case, example tester Mary. This is automatic depending on whose account you're logged into. So it should be your name, tester, or not tester, but say Patrick here, since I'm logged into my Patrick account. And then the status will be new or open. It'll usually say open. And then this is something that you can change on your own depending on what work you've done on it. And we'll explain a little bit more after we get through this. The environment details is usually something that you will have to write into in the box. Sometimes JIRA has a section for it, sometimes not, depending on how it's set up. But the environment details lists where you found the bug using the hardware. So in this case, we were using Chrome version 1234.56. That was our browser to get to this bug. So we want to be able to provide the engineer with whatever we were using to recreate this bug. And that's what the environment details essentially is. Windows 10 might not be necessary because it's an issue with connection. It doesn't have much to do with type of operating system. But if you had Chrome version and then you're also using an ad blocker, you want to put like what type of ad blocker you're using, or if you're using a VPN, Also include the VPN version and whatnot. And that's where you put that. Oh, sorry. And then our steps to reproduce this. So this whole bug report is basically for the engineer to look at and then see what the problem is, how you make the problem happen, and then try to recreate it, and then try to find a solution as to why this is happening and fix it. So steps to reproduce is very, very important. More important than the bug title and labeling it high priority. And I say it's right up there with environment. So you want to be very, very clear and be very simple with your steps. So the first step we would do, obviously we have our website open, or I mean our browser. So we would navigate to homepage or Amazon.com. Step one. Step two, click the big red button. Maybe there's a button on this web page, and that's what gives us our results. All right. So there's only 2 steps you performed, so you put them here. Sometimes people will skip right to click on the big red button. Well, it doesn't give us very much detail as to where that big red button is. Maybe the website has several big red buttons. So there's an exercise I would like you guys to do if you're very serious about QA and kind of learning and practicing. It's not homework that's graded or anything, but try doing the peanut butter test. So what you do is that you write instructions for making a sandwich. If you live in other countries, you probably might prefer jam. In the US, it's usually jam and peanut butter. And then write a step-by-step, every single step you need to do to create the sandwich. So step 1 would be gather your ingredients. Step 2 is put jam in front of you, right side up. Step 3, use your dominant hand to open the jam counterclockwise. Step 4, use butter knife to put into jam jar at 45-degree angle and scoop out jam. Be that detailed for every step. And then once you have this list of steps, go through and try to recreate it yourself. Just follow the instructions. Don't assume anything. Assume you know nothing about making sandwiches, or you assume you know nothing about how to get to Amazon.com with the big red button, right? So just kind of be humble and try to make it as clear as possible. And then after we have our steps, we're going to get the expected result. The expected result comes from the PRD again, and kind of our test cases that we've based it off of. And say the first feature is that clicking big red button should load this website in no longer than 5 seconds. That's the expected result. It should load and work as expected. That's usually found in the feature section of your PRD. And then our actual result. We just post what happened. 404 HTTP error observed. It's pretty clear. You don't have to write full sentences for this either. However, whatever the situation dictates, just tell us like what happened. And then for JIRA, it's very good that if you attach pictures or video, because it's easier to see how something is done rather than have to read something. Because a lot of our engineers, it's a very like a mixed bag of ethnicities and cultures here. So not everyone is reading and thinking exactly the same. If you get a video, it makes it a lot easier. Sometimes that will be a part of your complete bug report. Your manager will also require you to post the video somehow. All right. Is there any questions on the bug report page here? Please go ahead and ask me here while we're on the subject. I know there's probably some things we need to clarify. Yeah, if you guys are sending messages to me, I can see them. They're private, so it doesn't go to the public page here. But if there are a few questions, then we can move on, and I'll answer them as they come up. Cool. Right. Like I said that there was this new section over here, bug lifecycle. It says new. If we go back one page, we see that the status here. So we're going to be talking about the status and what this means and how JIRA kind of interprets this and how we interpret this. What if you find a bug, but the software developer can't find it? That sometimes happens. It's where the developer can't recreate a bug that you had found. You know, it's like it works for them, but no one else. And that's where you got to have really clear areas where you put in for your environment, because usually the situation is that they have something installed that you don't, or vice versa, where you're using something that they aren't, which is why you're getting the bug. In that case, you know, if the developer can't reproduce it, then the bug just doesn't get worked on, and your manager will have to figure out what to do with it. When can we start writing a bug report during this course? I think that is either next class or the class after that with Natalia. You'll have some homework, and then we'll start grading it. We'll have some websites for you to go over, and it's actually pretty fun because they're real websites like Sephora and stuff, and they have bugs on there. So the bug lifecycle here is it's our journey of defects from identification to closure. It varies from organization to organization, because in JIRA you can relabel these different things, but they're essentially all the same, and they'll be kind of the same words. If you use the dictionary, you'll be able to translate it or find a synonym for it. So what happens here is that you've created your first bug report, right? It automatically gets sent as new or sometimes open. And then you're going to assign it to a developer or your manager. And then it gets labeled as assigned. This is where the person is working on it, and they're actually going to change it from assigned to in progress as kind of like a step in between, just to show that they're working on this bug. And then once they are done working on it, they're going to assign it back to QA or whoever made the bug, and that will go back to assigned. And then you're going to change it to verification. There's another one up here. Or it might just stay assigned because you know you have to work on it. And then you're going to verify this bug. So once you say that, hey, this bug is still not fixed. I see that you made your notes, right, in the build from earlier that you say you have fixed it. I reproduced it, again, using the steps from the bug report, and it's still not resolved. Well, you then change it from back to your assigned, not resolved, but to reopen. You're going to reopen the bug, and you're going to reassign it back to the developer because he's got to fix it again, and say that he did it. You make another build, and then goes back to you. You're going to verify, and then say, hey, yeah, the bug is fixed. It doesn't. The issue doesn't appear anymore. Maybe there's another bug that happens, but the one that we're talking about is fixed. So we're going to say it's resolved, and then label it closed. And then the bugs get kind of put into another section where they all just get closed as the resolved. So you have your section of resolved bugs, and you have another section for all the bugs that are open and ones that are being worked on that are in progress. Can I put one ticket, different environment details? Maybe if you could elaborate on that, but if you have different environment details, Just try to, I would say, always try to make note of the type of software that you're using at the time to find the bug. Sometimes we get right into things and we're testing and things have updated in the morning, but we didn't make note of the version number of the software. Maybe the browser updated. So you got to kind of grab that before you start testing. All right, so there's some preparation you need to do. Bug report will be the same for all bugs identified by the tester. Yes, they will. So all the bugs that you find that you report are all going to look like this, from company to company, from tester to tester. This is the very general layout. They might include other things. They might want a very long summary and for some extra details, because maybe it's complex software. But for the most part, it'll look like this. Okay. So again, bugs go from new to assign it to a developer. They either get fixed, resolved, and then closed, or they do not get fixed, which is rare. I say that maybe only like 1 to 2% of my bugs have actually not been fixed by the time they get sent back to me, because the developers are doing their own little unit tests. So then it gets reopened, assigned, then back to you. There. And again, it looks a little bit different for everybody on JIRA because there's different labels you can add. Is there such thing as bug-free software, right? Again, no. You're going to want to try to make something really well, and your managers might even press you to try to find all of the bugs. And maybe you think that there's bugs out there, but you're not finding them. Which is why I think it's good to hire extra QA, to have another set of eyes. Maybe you need to take some time off or just do something else with your day during the evening to get a clear mind and come back to it, because there is always bugs somewhere. You always got to be thinking outside of the box. Computers and software that change the application will run on, continue to change, even while the code is frozen. What does this mean that the code is frozen? Well, at the end of a project, when it goes to the development to testing phase, you don't want developers to keep working on something and changing it while you are testing it, because then obviously you're going to see a whole bunch of new bugs and features you're not anticipating. So code is frozen means that developers have stopped working on it and they're not allowed to add anything to the build. Merely what it means. The operating system continues to evolve with patches and fixes. Even Windows updates all the time. And if you're having if you have a hardware thing that you're testing, Windows can update and then change that. How it communicates between the hardware that you're working on and Windows, that creates more bugs. And then aside from hardware and the OS, there's a number of like middleware products underneath most significant apps that will evolve. So I think if you're working on like AR, augmented reality, there's a whole bunch of dependencies and tools you use, and it's new technology. So these get updated quite a bit as well. So JIRA, I wanted to show you guys a little bit about what JIRA looks like, since we talked so much about it, and it was kind of vague. This is a project management tool that supports any methodology, be it Agile, Scrum, Kanban, and others. Kanban is kind of like this up and down column method where you move things left and right depending on their status. From Agile boards to reports, JIRA helps plans, tracks, and manages all software. We'll be giving you guys an account to use to make your own JIRA bugs. JIRA is it's pretty expensive, so it's for companies that are kind of like have a really big budget, but that are not in the billions and billions of dollars, right? So companies that have somewhere between probably like 10 million to 700, 800 million dollars in budget. So here we have, you'll see both these views depending on where you are in JIRA. And we can see at the top of here, we have our projects, the issues that we're going to find. Agile is not always there. And then a create issue button. We can click that to create bugs or a story again, which is just a piece of, which is a reminder actually to create a feature that's in the PRD. And then your account profile is up here and all your settings and whatnot. You'll be able to see everything that is to do for not only yourself, but for other people and the whole project. Ideation is not always there. In progress are things that are assigned to people that they're currently working on. And then obviously done are features and bugs that are currently closed, that they've finished working on them. This side over here is what a story or bug report kind of looks like. This picture is kind of like a story actually. So it says build Android application package. This might be a reminder to a deployment engineer to make a build for this particular day. But if this was a bug, what would the bug title look like? You might be responsible for like taking some code and then building an Android application from that. It's usually only like a couple clicks. It's not hard. You don't have to like code many things. But what if it fails? There's a problem with it. Maybe there's an update, right? So we found an issue with it, and it says build Android application package fails to build, or Android application package fails to build. This is our bug for our example here. We have, I'll try to zoom in on this actually. This is another bug with, let's see here, Google, because I think I can zoom, but it says I zoom, but nothing actually happens. I got 100%, 200%, and I'm sure that it all looks the same to you guys, which is frustrating. I want you guys to see this. But for a quick review, we have an area where you can add your description, where you're gonna be able to add your environment details, your expected results, your actual results, maybe a summary. And then if your engineers have questions, they can post some comments down here. And then off to the right, we have an area where you can see the assignee person, which is just a drop down that you can click on, and then your reporter, which will always stay there. The status, you can click between the different types of statuses that you have, be it in review or verify, open, close, in progress. And then there's also something called JIRA points. Some companies use this, and maybe Natalia will elaborate more on it. I didn't personally have to use it, and I think it's kind of it's silly, but it helps track how long things are going to take to work on something. And say you assign something 2 JIRA points. Well, that means it's not going to take very long, right? It might take like a couple days, like a day or two, maybe not even that. And it goes on a logarithmic scale. Not sure where it ends, something like 16 or 32, but the top end is like several weeks. So you're going to be dedicating 2 or more full sprints to this. And a sprint, again, was usually sprint now in Agile Scrum is about 2 weeks. However, the JIRA points goes differently by company. They'll assign, maybe they'll say that 2 JIRA points is actually 2 working days, or it's 1 week. But you'll find that out on your onboarding information package day when you first join the company. I want to try to move to the next page here. Yeah, so that's pretty much it with JIRA. There's not a whole lot to it in terms of actually bug reports too. Again, I really want to specify, or reiterate, being clear and concise with your bug titles and then your steps. Start thinking about in your daily life, like you don't actually have to write it down, but when you're going to cook something or you're getting in your car or whatnot, like how you might explain this to somebody, right? You're going to firmly place 2 hands on your 4 and 8 on the steering wheel, and then you're gonna, use your shifting wheel to shift. Think of it as that detailed, right? Let me get the chat up here again. Yeah, you guys can zoom on your phones. Yeah, if you guys have any other questions for now, we are almost done here. Just want to clarify anything that you guys have to do, and we'll be done for the day. And it can be questions related to just like bugs in general, or like how JIRA works, or situations you might find yourself in that you're having questions with, or what is a typical day in manual QA? So what do we end up doing for like a full day? My favorite part actually was because it wasn't as stressful as it was animating. So you typically are on your own for when to report to work. The culture, the lifestyle is that you have work assigned to you. You already know what you need to do, but as long as you perform and do your work that you need to do for the day, and you go to your meetings and you meet deadlines, how you spend your time is up to you. You can come in at 10 o'clock. I would never advocate that initially, but you can come in 10, 11 o'clock in the afternoon, or in the morning, and as long as you put in your hours and you finish your projects, then you're good to go. So I would usually come in at about like 9:30, get my coffee. We have a meeting at 10 o'clock where we go over everything that we were supposed to do from the previous day, what we did do, and then what we will be working on for the current day in the afternoon. And then I listen to all the engineers and what their issues are and what they're working on, because when they're making a new build, I'll be expecting these changes in that build. So I'll be able to see what it is. And I don't have to guess or bug them for details on their build. And then in the afternoon, I will do a test depending on the subject. I might do a full regression. So regression will mean that I've went over and tested on the new build all of the previous issues that we've had. Say maybe there's 100 bugs we found, and I will try to go back and find all these bugs again to see if any of them have popped back up again. It's usually very poor when we see regression issues happening. It's backwards progress. And in the afternoon, I will try to create some more test cases. I can see how I can be more useful to the team. I'm making a report by the end of the day, figuring out how many bugs I found, how many bugs I have fixed or verified, how many test cases we made. If there's any issues that are blocking, say that simple things like the office ran out of batteries, so I can't test the VR application without batteries for my controller. So I have to note that, and then they'll get me new batteries, and we'll continue on for the next day. What happens if a developer is not able to reproduce bugs in his environment? Well, then you have to spend a bit more time with them and try to figure out really why that is. Because if you guys are using the same version, the same environment, you should be able to reproduce. And if you don't, then there's a discrepancy somewhere. Somebody is not using the same thing. If it's not a very critical bug that happens, it might usually get swept under. You might have to revisit it at the end of the project. If it's critical, as QA, you're going to have to try to figure out why his isn't working versus yours is. With COVID, how are the days different? Is it a lot of Slack and Zoom meetings? I'd say they're actually like pretty similar in terms of having to start work mostly at the same time. People have got kind of lax. Most people kind of start their day a little bit later in the morning, but we still have our meetings at 10 o'clock. And we're communicating through Slack at my company all day. We were also using email. We have company email on a VPN. And I say maybe it's actually gotten a little bit harder because it's kind of easier to talk to new people face to face, especially if they're new employees, new engineers, about issues that maybe you know more about. It's coming through Slack. It's kind of hard to show them the tone that you're speaking and really telling them the details of it. There's a lot of room for miscommunication. And then I'm also getting kind of bugged later in the evening about performing work because I'm so close to my computer. Are you allowed to look at the developer's code throughout the day to help look for bugs in the code that we were unnoticed if you know some programming languages? Yes, that is a type of testing. I think it is white box testing, where you're able to see behind the curtain. You're able to see the back end and be able to start testing that way. So maybe the programmer, again, made some syntax errors, or maybe you're aware that there's a dependency missing and you're able to find it. Or maybe you found a user interface bug. You can open up that code and see where that line is on the code, and then maybe deduce like how to fix it or why that's happening. It was a lot easier doing that for Unity on a game engine because I can look at all their code. Some companies, they might not give you that access, but I think if you try to advocate that, they will definitely let you see it and use it because it helps the engineer. What tools are we going to use to take screenshots and videos of your work or projects you're working on? You'll find that there's a lot of built-in Windows applications that actually take video and screenshots just fine. Same thing for Mac and Linux. And then on your phone, there's recording devices. So if you happen to be working on mobile device projects, Android has an ability to record natively inside of it, and so does iPhone, I think now. But there's a tool called ADB that allows you to unlock this, and you can start recording straight from the phone to the phone, and then upload it off of the phone to your computer. So it's pretty easy, and it's something we will definitely show you how to do. If you have no programming language experience, what would you recommend to learn? We'll be able to rehire as manual QA tester without any programming language experience. Yes, you will be able to be hired without language experience. That's my situation. I'm not very fluent in anything, but I kind of know how Python works and whatnot. We'll be showing you guys not only manual, but automation as well. So you'll be able to know enough to construct automation programs with the programs that we help you use without knowing much language at all. So there's just a couple of commands that you need to run, and it's a couple of clicks, and it's pretty easy, right? And then everything that you need to know about the programming language, we will definitely show you in instruction. And if you wanted to get deeper into other types of programming languages, I'd say start learning languages after you get hired and you kind of know the environment a bit well and maybe what your company needs. Maybe you get hired as manual QA and they have a role for automation there that requires a different language that we've instructed. Then you can on your own start learning that, and it's pretty easy. There's tons of tutorials out there and ways for people to start self-learning. But the whole goal of this is to help you guys get your foot in the door, to be confident about what you're doing and what you're looking at. Being able to test is the most important part. Once you become a QA lead, QA manager, you hardly touch coding at all. My manager hadn't touched coding in probably half a decade. How do we decide the severity and priority again as a tester? So you want to definitely look at things that are affecting the performance of the application. Can the user access the website? Can the user see things that affect the website for it to make money? So are ads displaying? Can you add products to the shopping cart? Can you check out? Does the credit card section work? And if these are yes questions, they're most likely all very severe, right? And then issues that are more visual that don't affect performance. I was working on something, a medium issue, somewhere in between, might be when you look down at the ground, since I was in VR, maybe the textures are flashing different colors. That would be medium, because not many people are looking at the ground. It's just texture. It's kind of an easy fix. It didn't stop you from doing anything, but obviously it's jarring to look at since it's flashing in your eyes, so you don't want to look at it. And I would classify that as like a medium bug. For website, maybe it is something like the side categories button. You try to click something and it's supposed to expand out. Only half the time when you mouse over does it open up and expand. If it's half the time, maybe that's a medium bug. What systems do you think are best to use for QA, Windows or iOS? We're going to get you started doing everything you need to know for the most common QA jobs out there, but it's pretty easy to work with Windows initially starting off, and if you have a Android device, because they represent the largest amount of global market, right? But if you have an iPhone or a Mac, it's also really helpful because you can install Windows and use your Mac at the same time, or you can switch between. And then you have access to Xcode, which is somewhere to program or look at your bug log in Mac. How long does it take to become a QA lead? You can probably do it in 2 to 3 years, maybe 1 year, depending on the needs of your company. So maybe you get really familiar with the product, you've been there for a year, they want you to go to another project, and it's a bigger project, and they're gonna hire new people, they might make you the QA lead. If you have shown that you are like willing to always kind of be there on the project, if you want to like help out, don't ever show that you're kind of lazy. You know, always kind of be hungry, and then good things will happen. Want to know all the testing types that are performed by a single tester, or different testers will be assigned to different types. So I rarely have worked alone. There's only one project where I've had one QA, and it was one manager and one developer. So I had to test everything. There was a lot of stuff to test. It was 20 different phones and 2 VR headsets, and it was kind of complicated. I did all the regression, all the integration, all the sanity and smoke testing. Usually for projects, you'll have a manager who may double as your QA lead, and then 2 or 3 other QA. And you can divide that work up seeing how the manager sees fit. So maybe manager will task one QA to test one feature while you test the other. So maybe you might test the shopping cart, and then they might test category shopping. So maybe they might want to test the search bar, so searching. See if the filters work, see if sorting works correctly. What approach should we use to decide which tests to be performed manually and which tests to be done automatically? JIRA is the only software to create bug reports. So for how to decide what to test with manual or automation, usually tests that are done automatically are ones that are don't need any human input, but can be done with the program clicking on buttons. So if you're just trying to test, say, Amazon's shopping category buttons and making sure all the website's pages loads correctly, that might be automated. You can set in your automation program to just click this button here with this ID, and if it loads, then it's success. click the next one if it loads, success. Manually are things that are more like stress testing, where you're not going to test them all the time. Automation are things that you want to do over and over and over again, maybe every day or every week. And it would take a long time for a human to do it. If you have the program to run, then that frees up your time to test other things. Things that are done with automation are usually dictated by your QA manager, because it's going to take some of your time and resources to do it. And they're going to weigh the pros and cons of having it done manually versus automatically. And then JIRA is not the only software to create bug reports. There's a free one called Bugzilla. I think if you look at it and you can kind of go through it, it's free. But then, like I said, other companies that you get hired to, mostly the Fortune 500, all have their own version of bug reporting software. So as long as you're familiar with what we teach you guys in the next course on how to make bug reports and actually do it yourself, you'll definitely be okay. It won't be anything new. There won't be any surprises. If their program is substantially different, they will know this. They're also professionals, and you can just ask like, oh, how do I do this or get to this area? Or what's different? A good question to ask would be like, what's different in this as to opposed to JIRA? All right, guys, we are coming up on time. If you guys have any last minute questions, let me know. But otherwise, it's been really great talking to you guys. I will see you guys soon. I'll probably be grading some of your homework in a couple of days. But the next classes are really good. I'm glad that you guys have really definitely taken the first step to being QA. It might sound daunting, like you need to put in a lot of work, but this is not the case, because we've broken down everything super simple and easy for you guys. I wish I had this, and the reason why it's like this is not, this is a great program to be in, because there's always lots of QA positions happening. It's always going to be a staple. Where there are software engineers, there are software QA. And you might think that automation might replace some things. It definitely can't. And you will see that when you get hired, because it takes a long time to start programming automation, and it can only do one thing, right? So that is some of my lessons and thoughts for you guys. Be detail oriented, start looking for bugs in your daily life, and I'm sure it'll come to you guys. Cool. Hope you guys have a great rest of your night, and I will see you again tomorrow.